Okay, in this video I'm just going through some homework help questions from section 32.4, which is the radical rational equations. Here we've got a rational equation. To solve this, an easy way of doing it is to multiply every term by the lowest common denominator. The lowest common denominator between 5 and 2 would be 10, and there's an x there, so it would have to be 10x. So I'm going to multiply every term, this one, and this one by 10x. 10x, 10x, 10x. In the first one, 5 goes into 10 twice, so I've got 2 times 3, and there's an x, so it'd be 6x. 2 goes into 10 5 times x, this would be 5x. Is equal to, the x's will cancel, 10 times 1 is 10. Collecting like terms on the left side gives me 11. Divide both sides by 11. I get 10 11ths. So that's the first one. Next one, a little bit funner, lowest common denominator. I have to keep these together. So it would be an x plus 8 and an x. So I need to take this term and this term. I need to multiply them both by x plus 8 times x. X plus 8 times x. Okay, on the first one, the x plus 8's cancel. 4 times x would just be 4x. The next one, the x's cancel, so I'd have 6 times x plus 8. So now to go, I'll have to distributive property, so 6x times and 6 times 8 would be 48 is equal to 4x. Now I'm going to bring this 4x over to the left side, so I'm going to subtract 4x on both sides. I do that just so I get a positive x there, and then I'll subtract 48 on both sides. So I'll wind up with a negative 48 on that side. And now I'll divide both sides by 2, and I'll come up with x as being negative 24. One thing I haven't done yet, and I probably should do this with each question, is I should check my answers. So 4 over x I found to be negative 24 plus 8. Is that equal to 6 over, my answer was negative 24. Are those the same? So in the first one I have 4 over, that would be negative 16. And here I have 6 over negative 24. If I simplify, on this side I get negative a quarter. On this side I also get negative a quarter. That means that negative 24, correct. Question 3. Ooh, they're up in the ante a little bit. So first I'm going to need to factor that. So let's leave everything as is. So 12 over y plus 6 plus 2 over y is equal to 8y minus 6 over, that's the difference of squares, so y plus 6, y minus 6. That's a 6. So lowest common denominator, I need a y plus 6 in there. I need a plain y, and I have that already, y minus 6. So that'll be my lowest common denominator. So I need to take and multiply every term by that. So 12 over y plus 6 plus, I'm giving myself lots of room there, 2 over y is equal to 8y minus 6 over y plus 6, y minus 6. So each of those get multiplied by the lowest common denominator, which is y plus 6, y minus 6, and a y. Y plus 6, y minus 6, and a y. Y plus 6, y minus 6, and a y. Okay, now we get to cancel. So this step here is the ugly step, but after that step, then I don't have any fractions. Then I just can simplify what I've got. Okay, so in the first one, y plus 6 is cancel. So I'm left with a 12, a y, and a y minus 6. In the next one, the y's cancel. So I'm left with a 2, and then a y plus 6, y minus 6. On this side, the y plus 6 and y minus 6 all cancel, leaving me with a y and an 8y minus 6. Let me take a look and see if I'm happy there. Yeah, I think I'm okay so far. Okay, now I'll need to use the distributive property to come up with, to simplify it a bit. So this times this, so 12y squared minus 72y plus, this one I'm going to FOIL this first and then times it by the 2. So I'll have y squared minus 6y plus 6y will cancel, so it'll be minus 36 is equal to, again distribute, so 8y squared minus 6y. Let's just do that distributive property there with this term, so it'd be plus 2y squared minus 72 is equal to 8y squared minus 6y. It's a quadratic, so let's bring everything over to the left side. So I've got a 12y squared, and then I've got a plus 2y squared, and then if I bring this over, it'll be an 8 minus 8y squared. Oh, this should be a y. Then I have a minus 72y, and bring this over, it'll be a plus 6y, and then I have a minus 72. Did I get everything? 12, 2, yeah, and minus 8, minus 72, plus 6, yeah, and a minus 72, good, equals 0. Okay, collecting like terms, 12 plus 2 is 14, minus 8 would be 6. Minus 72 plus 6 would be a minus 66, I think, y, minus 72 equals 0. I think they're all divisible by 6, so let's do that. Divide by 6, everybody. So I'll have y squared minus 11y minus 12, I think, is equal to 0. Quadratic factor, so y minus 12, y plus 1, I think is the correct factorization. Then the 0 property, so y is either 12 or negative 1. Now, probably should check, that was a whole lot of work, and checking up there might be a little bit dicey. However, when you look at it, I get 12 and a negative 1. If I try and put a 12 or a negative 1 in either of those spots in the denominator, none of them come out to 0. So I'm pretty confident, confident that my answers are correct. Okay, next question. Okay, so now let's try some radical equations. To solve radical equations, you need to isolate the radical and then use the principle of powers. So it's already isolated, the radical, so I'm going to square this side. If I do that, I need to square the other side. On the left, the square and the square root cancel, so I'm left with 1 minus 6x. On the right side, 5 squared is 25. Okay, collecting like terms or moving things around, I'm actually going to move the x to the right side so it becomes positive. So I'll have 1 is equal to 25 plus 6x. Then I'll subtract 25 from both sides. 25. So that'll be a minus 24 on this side is equal to positive 6x. Divide both sides by 6. And you get x is equal to negative 4. Some things to watch on that. Just make sure you do isolate the radical each time. And then when you square things, make sure you square the whole thing on the one side. Maybe I'll show you some more questions where you'll have to do that, like this one. Okay, I need to isolate the radical. Make it just a bit bigger. So to isolate the radical, here's the radical. So I have to get rid of this 1. So I'll add 1 to both sides, leaving me with this. 3 plus 1 is 4. Now I can use the principle of powers to square both sides. That square cancels that, leaving you with 2x plus 1 is 16. Subtract 1 from each side, divide both sides by 2. So I come up with 15 over 2. Next question, a little bit more involved, this one. Again, though, I need to isolate that radical, so I'll subtract 9 on both sides. Getting root of x plus 81 is equal to x minus 9. Now I can use the principal power, so square this side, square this side. So I have x plus 81 is equal to, and here's where most people make a mistake, where they just try and square the x and square the 9 separately, but you need to write them both out, because if you FOIL that, you don't get what you think you would get just by squaring both of those. That's incorrect to do that. So FOILing this, I get x squared minus 9x minus another 9x plus 81 is equal to x plus 81. Now, since I have a quadratic, I'll bring everything over to the right. So I have x squared. This will be minus 18x. If I bring this over, it'll be a minus x. Plus 81. If I bring this over, it'll be a minus 81 is equal to 0. So I have x squared. This will be a minus 19x. Oh, and that cancels. So now I can't factor a trinomial, but I can do a common factor. So to get a common factor, I'll just take an x out, leaving me with x minus 19. And then, at this point, I can use my zero property. So either x is 0 or x minus 19 is 0. So this one, I'll add 19 to both sides. I get a positive 19. So my answers are 0 and 19. Now, like I've said before, always a good idea to check. Let's just check each of those and see what I come up with. So the square root of, let's try 0 first. 0 plus 81 plus 9, is that equal to 0? 0 plus 81, that's 81. And the square root of 81 is 9. And 9 plus 9, yeah, not equal to 0. That one can't be an answer. Let's try the other one. Square root of 19 plus 81 plus 9 is equal to x on this side is 19. 19 plus 81 is 100. Square root of 100 is 10. 10 plus 9, 19. Right on. So that is the correct answer. Okay, here's a double one. This is one where there's lots of work to this one. So first, isolate a radical. So I'm going to add root x minus 9 to both sides. So I'll have root of x plus 24 is equal to 3 plus root x minus 9. Now there's lots of steps on this, so I'm just going to pause every once in a while to make sure I'm doing it right. Okay, now I can use the principal power, square this, and square this whole thing. Notice I don't square each thing individually. Incorrect. Got to square the whole thing. Square and the square root cancel. So I have x plus 24 is equal to, let's write out 2 of these. And then we'll FOIL them. So 3 times 3 is 9. 3 times that will be a plus 3 root x minus 9. And this times this will be another plus 3 root x minus 9. And this time this, as you saw in the other video, will just come out to x minus 9 is equal to x plus 24. Okay, looking spectacular so far. I can combine these. That'll be a 6 root x minus 9. And then why don't I take this stuff and move it to the left side? So already there I have x plus 24. If I bring this over, it'll be a minus 9. If I bring this over, it'll be a minus x. If I bring this over, it'll be a plus 9. Notice what I'm trying to do there is isolating the radical. So x minus x, oh, they cancel. Nice. Minus 9 plus 9, those cancel too. So I just have 24 there. Nice. 24 is equal to 6 root x minus 9. Both sides are divisible by 6, so I'm going to do that. Divide both sides by 6. So I'll get 4 is equal to root x minus 9. And now I can do my principle of powers again. Square this side, square this side. So I have x minus 9 is equal to 16. And then, last step, add 9 on both sides. So I get x is equal to 25. Yeah, I think that's right. We can always check it. Let's check it. That's a good idea. Okay, let's check it in green. So root of, we got 25, right? So 25 plus 24 minus root 25 minus 9, is that equal to 3? 25 plus 24 is 49. 25 minus 9 is 16. Square root of 49 is 7. Square root of 16 is 4. 7 take away 4, 3. Right on. So that means my answer down here of 25 is correct. All right, hopefully that helps you with that homework on rational and radical equations.